Now, this is a session about a few of my favorite C# language features. My favorites, not necessarily because they're awesome, some of them just my favorite because they are a bit special. There have been a few discussions and a lot of drama, and I love drama. I live for drama. The slide behind me is sort of my humor and how this session will be, so you have been warned, and you do have the opportunity to leave within the next 10 seconds if you do not get the joke. Hip hip hooray! Hip hip hooray, hooray? No? No? See, I warned you. All right, my name is Classon. You can see my blog there. I write books, funny books, technical books. I have a blog and so on. I work as a backend developer at Power Factors. I have 2 boys, and I used to be a clinical dietitian. I recently came back from parental leave. This is not my Halloween outfit. This is how I look after a day at work. And I have to say, coming back from parental leave for a year, because we have quite long parental leave in Sweden, was a shock for me. It feels like I have to start all over again. It's very interesting how fast you forget things. So I come back to work. They've reorganized everything. Now we have squads and we have tribes. You wouldn't believe how bad the Wi-Fi was there. And we also have something called floating teams, and I don't know what they do, because they just floated by and I never got the chance to ask them. But I believe their teams sort of just go around and help other teams. So our product managers, as much as I love them, every couple of weeks they will read a new book, the goddamn books, or they will go to a conference and they'll come back to work and do not conference-driven development, but sort of conference-driven product management. They read a new awesome word and we have to reorganize everything. And it's very, very confusing. But it's not the first time I've had to recap everything I've learned, because I've been away for a while. I did have my first child a few years ago, and I had the pleasure of standing on this stage, I think this room, 9 months pregnant while having contractions, hurried home and delivered a baby. I've spoken at Øredev 5 times, I believe, and this was the first time I had a little bit of an identity crisis, and also a lot of time and apparently money to color my hair a lot. And this was back in 2012. This was when I had started learning programming. So the story goes like this. I used to be a personal trainer and clinical dietitian, and I got really tired of looking at my awesome arms and decided to do something that required no physical effort whatsoever, except my wrists, which are incredibly strong now. So I learned programming. And in 2011, Hello World looked like this. And now I come back to work and it just looks like that. It's just one line. What happened? So when I started learning programming in 2011, our teacher insisted that we would just use the basics. So in 2011, I believe that C#4 even was out, but he didn't want us to use anything beyond C#1. I don't know if any of you were around when if you started there when C#1. It was super duper basic. It was more or less of a little bit of a Java envy, if we can call it that. But teacher didn't want us to use anything beyond that. Because basically he didn't want us to do this. This is where you install ReSharper and you just gladly accept all its recommendations. For example, would you like to convert this into a link query? And he'll spit out this super long line. And yeah, the fewer lines you write, the better, right? Unless you work for Twitter and have to print out your code. It's just a rumor, but it's a funny one. So C#1, we had this stuff. It was like giving birth. I was told, I have given birth, I disagree. And then there was C#2. Now in C#2, we got generics and a lot of lovely stuff. And generics was one of the things that our teacher didn't want us to use. But nonetheless, I really wanted to understand more. So I made a deal with the teacher. I was allowed to use more than what was offered in C#1 if I could explain what the types did and how they were implemented. And what's really interesting about list is that list yesterday, for me last evening, ended up being a 2-hour-long discussion with the Java developer that continued during the night while I slept. People continued the discussion on Twitter, and nerd crush, Eric Lippert replied to one of my tweets this morning, and I am in love. So the way list is implemented, and I'm sure a lot of you already know, it has an internal array that it keeps resizing when you add items. Not every single time you add items, it has specific logic for that. And what's really interesting is that list has a default capacity of 4. But when you create a list, the capacity is 0. And once you add the first item, the capacity is 4. Which was super annoying when, even at my current workplace, I see stuff like this, creating a new list and passing in a 0. Because in the constructor, you can pass in the capacity. This will not change the default capacity. The default capacity is a constant. You can't change that. But I see this all the time. And this is basically useless. And by the way, you probably see that I'm using regex there. So here comes another one of my beautiful jokes. So when you instantiate a list and you pass in the capacity in the constructor, as you can see, it will do absolutely nothing. There's no point in passing in a 0 if it's already set to 0. So the discussion even was yesterday with the Java developers, like, is it the same in Java? No, it's not. The implementation is fairly similar, but their default capacity is 10. Why 10? And why 4? Here is my theory. And there's no science behind this, but I go like, I have 2 hands, I have 10 fingers. 10. And then in C#, they go like 1, 2, 3, 4, and I forgot what comes afterwards, so 4? It's just a theory, but I'll get back to this later. Now, if you want to look at how the implementation, there are a couple of sources, as you maybe saw. I know I didn't have the URL in it, but I think it's source.net, and then it's like reference source.net or something. It's available online to see how the most common libraries that we use, how they implement the types. However, if you want to get really fancy, you can decompile. You have reflector, you have just peak, and just decompile. I can't remember all of them, but there are a bunch of decompilers that you can use. However, what you can also use is Visual Studio. I don't know if you knew this. It goes like this. You start debugging. You can only do this when you're debugging. You start debugging. You click on Windows. Under Windows, you find modules. You will not see this unless you're debugging. Then you select the library, decompile to symbol file. This means that you can start debugging. However, if you actually want to generate the class files, you just select extract source code, and it will show up all of it under miscellaneous files. I don't remember the exact name. But be wary, as you can see here, you see the magic number 4. That is the default capacity. So when it decompiles, it's not going to turn it into its original implementation. It's going to simplify it a little bit. So some information is going to get lost. So it wouldn't be my go-to. However, if you need to debug or look at source code that otherwise is not available to you, Microsoft is more than happy to help you with Visual Studio. Now, I like to listen to podcasts, and .NET Core podcast is one of my favorite podcasts. Highly recommend it. And I listened to episode 104, where Mats Torgensen talked about C# and language development. And he told a story about the first language feature he got to work on was dynamic. It was that C#4, I believe, the dynamic keyword, a simple keyword that did a whole lot of magic. And he talked about how excited he was about working with dynamic. This is my husband, after stepping on a Lego. No, I'm just kidding. It's not my husband, but I can dream, can't I? Just kidding. So the dynamic keyboard keyword consists of, I guess you could say, three things. First of all, there's the keyword, which tells the compiler to move on, nothing to see here, because otherwise you just get a red squiggly. You have the expando object, which you use to build dynamic objects, and then you have the dynamic object if you sort of want to create your own magical dynamic object. And dynamic let us do things like this, which was so exciting, because suddenly I could do whatever I wanted. It was like writing in a dynamic, fantastic language, such as JavaScript. Not JavaScript. That would not be on my top 10 list. But it was like JavaScript on Adderall, but prettier, all right? So you could do stuff like this, and it was so fascinating that you could actually cast it back to an iDictionary. How? Why? Why can you do that? Well, again, if we look at the magic of source code, we can see that it implements an iDictionary. And this is the reason why you want to look into how language features are implemented and how types are implemented, because you want to know what's happening underneath the hood. But one thing that Mats said in the podcast, which I found really interesting, and it's actually completely true, because I remember the excitement about dynamic. Everybody talked about dynamic, and it was the coolest thing ever. Was it Simple Data that Mark Rendell wrote, this OR mapper that was completely dynamic? I remember using it when I was working as a consultant, my first job, and it was fantastic, except for one thing that Mats talked about. He said that with dynamic, we thought this was going to be the next great thing, best thing ever. A little bit of language envy that C# wanted to evolve beyond this object-oriented programming and allow for more crazy stuff. However, what happened was this. Suddenly, not suddenly, but people started using more and more devices. They weren't as strong as the ones we have today. People were relying more on cloud resources, where you often have a pay-as-you-go model. And I sure did on Azure, and it's really hard to delete resources you're not using. There's always a disk lying around that you need to pay for. But performance was unfortunately something that didn't work well with dynamic. I don't have the time to walk you through what happens under the hood with dynamic in what the compiler actually does, but it's a lot of work and it does affect performance. So, I mean, this is not an actual conversation, obviously. I am just making fun of dynamic. So dynamic turned out to be not disappointing, but it just didn't turn out to be as big as they thought it would be. But then we got this, a sync N08, a true diamond in the rough. Now this was all about responsiveness, and we did have, I mean, we could write asynchronous code before these two words came to be in C#. However, what these two did, together with a lot of libraries implementing synchronous methods as a twin to the synchronous methods, it made it really easy for people who do not understand asynchronous programming and just maybe even understand it, but it was more complicated to write asynchronous code, and then suddenly it became super easy. You didn't have to know anything what was happening. The only thing you had to do is use async and await, and be prepared to be abused if you did an async void. Which, by the way, was only added for event handlers. So let's get a little bit more technical, right? So the compiler does something called lowering. I don't know if this is an official term. I read it on the internet, so it must be true. But it does something called lowering, and I'll show you how it looks in the GitHub repository. But lowering basically means when it takes more, what do you call it, more like high-level C#, such as async and await and dynamic, and then it takes it and then it sort of rewrites it to C#, but it's more complicated, but it's also readable. So that's what lowering is. And by the way, limbo is how I snapped my ACL, which you can see the thing I have on my knee. And what's the time? Do I have time for a very short story? Funny story. Do you want to hear it? Funny story? All right, this might get cut from the video, so enjoy the moment. Channel 9 was interviewing me, and they asked me, where do you want to do the interview? And I was like, let's go to the top of a mountain. I just did surgery on my knee, but we can do it. We went to the top of the mountain. I think it's 800 meters straight down. It's awesome. It's where my parents live. But true story, I did shrink my clothes. So I shrank my clothes. My bosom was a bit too noticeable. So when I got the video, they sent me the video, and I was like, no, I cannot have my breastises on display like this. So this guy working for Channel 9 video team had to painfully, during 2 weeks, track my chest across the screen, and as you can see here, color in the cleavage. And he was sitting with his back to the door, so his screen would be the first thing you would see when you walked by the door or in. And the only thing that the team told me that they only saw my breastises on the screen for 2 weeks, and to this day, he's still traumatized. Anyways, back to the lowering. If you go to the Roslyn GitHub repository, you will see a folder called lowering. I recommend everybody to go there and have a look. I'm not going to claim that I understand absolutely everything, but I do understand more than before I looked at it. And you'll find things such as the async method builder collection. So let's take a look at what happens. Say I have this asynchronous method here. What happens is this. This. It's a little bit difficult to read, isn't it? All right, let's see if I can walk you through it. So we start at the top. It has a few fields to hold the state, the builder, and task awaiter. And inside the constructor, if you go further down, you can see that we are creating a default state machine. And this is one of the classes you will see in that Roslyn folder I showed you. And it goes ahead and creates the builder for a state machine. It sets the state to created and nothing else. And then it goes ahead and kicks off by calling move next. So if we go to the move next method, which is this one here, I have to look at the screen because otherwise I'll twist my neck. I've added some comments here, and I'll make this code available so you can read it afterwards. It has the awaiter, and then it calls that asynchronous method that we called in our asynchronous method. And as you can see, it goes ahead and gets the awaiter. It sets the awaiter inside the method, and then it checks if maybe it has completed immediately. Probably hasn't. And if it hasn't completed, it sets it to awaiting, assigns the awaiter, and so on, and it calls move next, and so continues. So it's a lot of things that happen in the background, and it's not code that we want to write ourselves. However, you will find yourself often in situations where you want to know exactly what happens. And also, why default capacity of 4 for list? Why? I'll get back to it later. I'll skip that part. Now, the async task method builder, you can also view the source code for it. And this is the create and start that I was talking about earlier. There was a really fun competition on Twitter about compiler lowering by Matt Warren. I don't know if any of you saw this competition. So basically what a compiler does, it does a lot of the heavy lifting for us with lowering. So it takes something simple and it generates the code for us. And you've probably noticed that in the last few versions of C#, we've focused a lot on boilerplate code and sort of removing that and making it easier so we can focus on the actual logic. Now, we had a competition where you try to generate as much code as possible by just writing a few lines of code and see how much work can you put the compiler through. And somebody shared my latest commit, apparently. Somebody managed to generate 8,000 lines of code with that. So if you want to have a lot of fun, you can go to sharplab.io and in real time, as you type, you can see what the compiler would be doing. C#6. C#6 was really interesting, because here are the language features that we got, except the second one. Do you remember when they talked about primary constructors and how we would get those? Well, that was actually scrapped pretty much last minute, unfortunately, but we will get back to it later. And if you're curious as to why, you don't necessarily, well, I had to use the Wayback Machine since the code is not in Codeplex anymore, but you can view the discussion there. But the discussions have continued on GitHub. And these discussions are gold, which you'll see why at the very end of the session. C#7. This one is when we started releasing new releases more frequently, sort of gave the impression that we were doing more work, but actually no, it's just instead of waiting until, for example, with patterns, instead of waiting until we had everything pattern related and ta-da, thank you for waiting 20 years, they decided to just get something working, ship it, get some feedback, and continue working on it based on the feedback, which is a fantastic approach. But that also means that bigger language features are spread out over language versions. And this started in C#7. I think they had like 4 separate releases with C#7. C#8 was the first version that targeted core. And there we got one of the probably most debated, discussed features. Default interface methods. Okay, can I see a reach of hands, those that do not like the idea of default interface methods? Only 3? You have not heard of the diamond problem? The diamond problem, multiple inheritance. Okay, so the diamond problem goes like this. If you were to allow multiple inheritance, which only some crazy languages do, like C++? Yes? No? Yeah? Yeah. They're crazy. So if you have object A implements a method, and then you have object B and C inherit from object A, and then you have object D inheriting from both B and C, and you call that method, which method do you call? Now, this is not really a problem with interfaces. So interface is it's not really multiple inheritance. However, it does give you the opportunity to sort of like fake inherit. At least you get an actual implementation. And this is why there are 2 reasons why at first, at least in the beginning, this was very unpopular, the default interface methods. One was that an interface is a contract. You do not breach contracts by forcing your implementation. Says everybody who's never read the terms of conditions for whatever social media site. We know at the very end it says, forget everything that I said, I might change everything at any moment and your firstborn is mine. And that's probably how it goes with interfaces now as well. So you can have now default implementations. However, the compiler will be very kind and will let you know when you're doing stuff that you're not allowed to do, because the method implementation is in the interface, it's not in the class that implements the interface. So if we're moving on from an unpopular feature, which is actually the reason why this exists is not just to mess with us, it has a lot of benefits. And one benefit is, say that you are an open source writer and you create a library with mucho importante interfaces, right? I'm not good at Spanish, but mucho importante interfaces. And then you decide that you need to add more to that interface. That's going to be a breaking change and it's going to be highly unpopular. So this is one of the things that it would allow you to do, is that you can make changes without breaking it. But then came finally records. We had been waiting for this forever and ever and ever, watching other languages have them and use them, and we wanted something similar. Apparently records were the best thing since sliced bread, unless you're on a low-carb diet. Records, what is it? So a record in C# is a class or a struct, I'll get to that soon, that provides syntax and behavior for working with data. And it's great when you want to work with data where value equality is really important. And there's an example there, and that is a full example. Public record bread type eval carb count. That's the constructor. Do you recognize this? Ah, we finally got our primary constructor for the record type, however, and not for the class. So if we take a look at what actually happens underneath the hood with records, because this is quite simple to define, however, there's a whole lot happening in the background. So if you take the public record here, and this is a record class, not a record struct. It creates all the properties with their backing fields, and you also get a couple of extra methods. And we didn't get just the record class, but when we got the record class, people were very quick to say, record class, but I have my read-only struct. And Microsoft was like, hold my beer, now you have a read-only record struct. Which one do I use? The internet and Stack Overflow is full of those questions. And a lot of people are asking what happens underneath the hood. Well, it's all available to us. If you want to see what's underneath the hood, just lift the hood and take a look at it. So in this example, I've been using SharpLab to show you. And I was, see how I'm doing for time. Okay, no, I'm not going to have time. I was going to go through the code and show you. But I'll see if I have time at the end. So with C# and C# 10, we got a lot of cosmetic goodies. And believe it or not, when I did a poll on Twitter, the most popular language features so far were absolutely records, but then were the top level statements and file scope namespaces. So more again of the cosmetic goodness, and also string love. And a lot of people ask, what about C# 11? What do we get in C# 11? I can't talk too much about C# 11 because there's a different session that focuses solely on that. However, I do want to talk about one feature that nearly made it, but then didn't. This is probably the biggest pull request they had to revert, the parameter null checking feature. So this got a lot of attention. The purpose of this feature was basically to make sure that you're not passing in null in a method. And it gets a little bit confusing. So instead of passing in an argument in a method and then checking whether it's null or not and then throwing an exception, what it would do, it wouldn't even go to the method body and just immediately throw the exception. And those two exclamation marks would do all the work for you. And it was merged and it was ready to go until somebody, Dustin, said, wait a minute, I saw this thing on Twitter. What is happening here? And I don't know if you noticed there that there were the conversation like 77. This is just one part of the discussion. This is a very, very, very long thread. And it seems like a very simple thing to add to the language, right? And something very, very beneficial. However, it is more complex than that, because a lot of questions arise. First of all, what does it mean at how it look at null? Do we allow null or do we not allow null? Or are we just trying to say, okay, you can have null, but just a little bit, not too much. How do you deal with this? And that was one of the problems, that it makes it more confusing. Discoverability is low, and how do you deal with constructors? And a whole lot more. And also, when they did, when I tried to look at the files and the actual implementation, GitHub crashed on me. Now, this feature didn't make it, and who knows, it actually will make it in the future. Make sure that you subscribe to notifications for the repositories, but you might want to add a filter of sort, because there's a lot of discussions. And talking about discussions, back to C# and the internal array. So, there we go. This is it. Before I show you that slide, where's my friend, the Java developer? There you are! All right, Simon, right? Yes, Simon and I yesterday maybe followed by a glass of wine or two, got deep into the discussion about the differences between Java and C#. It's funny enough, started talking about interfaces and default implementation of methods, which Java has. And I'm so sorry for accusing Java for having like true multiple inheritance. It didn't. I know nothing about Java, so he gave me a book. So I have to read that book now. And apparently, I didn't know this, but in Java, when you write an interface, and this just blows my mind, you do not prefix it with an I. You don't do I door. You don't have a door that implements I door. And it doesn't have an I handle, or an I exist, or I loggable, or I likable. There's no I. And it just blows my mind, and also equally amazes other people when they hear that we prefix everything with an I. And interfaces in C# with inversion of control has sort of gotten into, sometimes it feels like I'm writing Objective-C, and I'm just writing a bunch of, it's just header interfaces. We're talking about this, and then we started talking about lists. Like, okay, if there's a difference in that, what's the difference in implementation of lists? Because C# came after Java and was very much inspired by Java, so I'm just assuming it was meant to be an improvement. Well, the internal array in Java has 10, as I mentioned, but we do not know why. However, Simon made sure to ask on Twitter, and we were pretty surprised that the actual author behind ArrayList replied with regrets. So it was some sort of empirical study, and then they went like, well, yeah, okay, all right, we'll set it to 10. It seems fair enough. The discussion continued during the night, and I didn't quite follow it, and I didn't notice that the .NET team started replying as well. And it turns out that this might not be, I mean, it doesn't necessarily have a reason why it uses 4. It maybe made sense back then, or maybe they actually didn't put a lot of thought into it. So what I'm going to do now is I'm going to submit a language feature. I'll just show you how that is done. You want to see it on the screen as well, right? Yes, rookie mistake. I told you it's been a while. All right, here we go. If you go to the C# language, so this is not actual implementation. This is where they have the language specification, and you can follow a lot of the discussions. You can watch this. You can read this on their what's it called, Microsoft Learn now, as well. And I just want to show one more thing. Did you know that if you type dot, it will open it in an editor in the browser? I'm the only one who didn't. I'm supposed to know this stuff. I'm on like .NET MVP, important, you know. But yeah, I didn't know this. Anyways, if you go to issues, you can submit a new issue. And here you can select create a language specification, or propose a language idea, or ask a question. So, category, language idea, re-evaluate the default capacity for list of T. I'm taking this whole discussion from yesterday way too far. The current default capacity for internal array is blah, blah, blah. I reckon that we should reconsider whether or not 4 is the optimal number. And also, why not let the user decide what the default capacity should be, and also how the internal array should grow. And with that said, yes, I have searched for similar discussions. Should I do it? I did it! Don't crash. Yay! And I'll just blame it on Eric Lippert, because he replied to my tweet and he said, yeah, well, it's not a terrible idea, which I read as, Iris, this is the best idea I have ever heard, right? So, with that said, now I do have a little bit of extra time, don't I? I have 5 minutes. I have 10 minutes. Holy, you know, that was 79 slides. Wow, all right, okay, cool. So let's take a look at this. So this is SharpLab. Have you used SharpLab before? This is the best way to just decompile code. So I'm going to do just a quick comparison here. We'll start off with a lot of people ask what's the difference between a record struct and just a read-only struct. So this is what actually happened. So I've generated here, created a struct type, bread, and this is what the compiler actually creates. So we can ignore the stuff at the top, and we'll scroll back down here. It generates the backing field and the properties and so on, and that's basically it. However, if we take a look at the record, the read-only record struct, my tongue is getting tied, you get a whole lot more. Backing fields, properties, yada yada. But then you also have a bit more. You have a nicer toString and also print members, and it also does some equality comparison. Now, these are things that you absolutely can implement yourself, but it just means that you sort of get it out of the box. So those are some of the differences. Now I want to show you some of the other sources that are used. I find it easier to add it at the end of a session, so it's not so much back and forward. I'll go again just to the list here, just because I know where it is. So source.net, this is where you find everything, the latest version of .NET. And there's an equivalent website, I don't remember the URL, but for .NET 4.8 if you want to look at the older stuff. So this is where you can see everything in the source browser here. On the right-hand side, you can see the document outline, and it makes it much easier to find the fields and the properties and the methods as well. And you can take a look at how it is implemented. So these are two resources that I have been using a lot to understand more. Because back in the days I would mostly use decompilers, but that's a lot of trouble. So there's the C#lang repository, and then there is also let's see, just Roslyn, and then there's also the Roslyn repository. And this is where you'll actually find the implementations. And as you saw the previous window here, this is lowering, and this is where you can look at, for example, how the state machine writer works and a whole lot more. So with that said, I'm just going to go back to this, let's see, from current slide. All right, we've submitted a language feature, and this is my final slide, and this is called the QR roulette. And I'm just assuming this part is not going to make it in the video. Anyways, one of them points to my website. Contact details is @iris everywhere, like @irisclasson.com. And I write books, some funny books, some technical books, if you're interested. And there's also pictures to me giving birth. So, best of luck. Thank you very much.